Hello everyone and welcome to Gradeup. My name is Ashish Rawat and today this session is dedicated to surveying. Okay. Now in this session we will be discussing important questions related to surveying. Okay. So let's follow first of all take queries of students who have commented before the session. Now a student was asking about the session on water resource. Okay. So the session on water resource is upcoming. Okay, after surveying today's session, the only subject left is water resource, in which irrigation and hydrology will be covered. Okay, so this session will be either on 31st of Jan or 4th of Feb. Okay, so the exact date will be communicated to you, so don't worry about this subject. Okay, we will be taking the session. We'll wait for more students to join this session. Okay. Amar Pandit is asking to take more questions on photogrammetry. Yes, Amar will be taking questions on photogrammetry as well. Okay. So, in surveying, let's talk about the weightage in gate. Okay. Now, in gate examination, every year about 3 to 4 questions appear. Okay, on an average. In terms of marks, if you see 4 to 5 marks. Okay, so this is the weightage of surveying in gate examination. Okay, so this is about the weightage. Okay, now let's quickly move to the session now. Now in surveying, there are a lot of small concepts related to which questions in gate examination and other competitive examinations have appeared. Okay, now the first topic for which we have taken question is linear measurements. Okay, so now a student has asked question to add questions of limiting length of offset. Now in gate examination, the question related to limiting length of offset has not been asked till date, so we should not count that as an important, but I will discuss the concept related to limiting length of offset. Okay, so don't worry about that. Now first you can read the question from the screens. Now given, now what is given to you? There is a chain of length 20 meter. Okay, so designated length of chain, okay, that is L dash. Okay, so, sorry, it is L. Okay, designated length of chain denoted by small l, that is 20 meters. Okay, now the second thing which is given to you is measured area. Okay, that is 3200 meters square. Okay, now you are given with the true length of chain, that is L dash, that is 19.8 meters. Okay, so this is the data given to you. Abhishek Thakur, your answer is 3136.32. Yes, it's correct. Okay, so now in linear measurements, this with this data you have to calculate the true area. Okay, so this thing you have to calculate. Now you know the relation. Okay, so designated length L multiply this whole square multiply by true area is equals to true length of tape whole square into true area. Okay, so this is the relation which we will be using. Okay, so here the relation for true area will be, it will become L dash by L whole square multiply by measured area. Okay, so here it is 19.8 divided by 20 whole square multiplied by 3200, and that is equals to 3136. 36.32 meter square. Okay, so this is the correct area. Okay, now the same concept can be obtained if you have given with measured, in place of area you are provided with measured length, and you have to obtain not true length, true area, that is true length you have to calculate. Now same relation but without square you can use. Similarly for volume you can do. Okay, so same relation goes for the length. Okay, length will be, here it will be 1. Okay, now for area it is 2, and for volume the length to the power 3. Okay, so yes, I think everyone has answered this question correctly. Okay, so you can quickly take a screenshot of this, and I will be discussing now the limiting length of offset, the theory of limiting length of offset. Okay, so limiting length of offset. Okay, okay. So as you know, in survey you have to take offsets from the main chain line. Okay, so there is a certain length up to which the offset can be done, offsetting can be done, so that the error is limited to a certain value. Okay, so what is limiting, what is the definition here? It will be the maximum length of offset so that the error in measurement is not more than 0.25 mm. Okay, so unless otherwise specified, this is the value of error which is restricted. Okay, so the maximum length of offset so that the error in measurement is not more than 0.25 mm, that is the maximum value. Okay, so in this there are two cases. Okay, so case 1 is related to direction. Okay, when error in laying out direction, error in laying direction. Okay, so in this case, let us suppose this was some station A. Okay, and you are intending to take the offset P here. Okay, but while mapping you have taken it incorrectly to the value of P2, P1 here. Okay, so there is an inclination of theta. Okay, so this value, if this value is L, this value is L sin theta. Now for this case, where error is in laying direction, in that case L sin theta by S, S is the scale, should not be greater than 0.025. Okay, where S is 1 centimeter, this is the scale, 1 centimeter to S meters. Okay, this is the scale. Okay, and L is the length of offset. Okay, so this value will give the limiting length of offset when error is in laying direction only. Okay, now the second case, when the error is in laying direction as well as measuring the length. Okay, you should for the numerical purposes you should remember this relation. Okay, now case 2, error in laying direction and length as well. Okay, now in this case, if suppose this is point O and this is point P, and let us suppose in laying length X error is there. Okay, so if you take this value as theta similarly, and this value is P2. Okay, so if you see, this value is L. Okay, this value was L, so L sin theta, and this is the net error. Okay, now in this case the relation becomes L sin theta by S whole square minus S square should not be greater than 0.025. Okay, now the question related to this limiting length of offset has not appeared in GATE examination till date. Okay, but For numerical purposes, remember these two equations, okay, this one and this one. In this case, there is error in laying direction only, while in this case, error is in laying direction as well as the measuring of length, okay. So you can take a screenshot of this, and we'll move to the next question now. Okay. Now this question is related to compass survey, that is bearings, okay. Now there is a lot of confusion with respect to the declination, true meridian, magnetic meridian, okay. So I hope to clear the doubts of students with this question. You can read the question and start solving, okay. Okay, compass surveying. Okay. Now, let's read the question. Line AB has a magnetic bearing of 44 degree 30 minutes. Now, in 1910, okay, when the declination was 4 degree 30 minute west, the magnetic bearing was the same line in 1990 if the annual change was 6 degree eastwards. Okay. So, now in 1910, okay, 1910. So 1910 में क्या डेटा अवेलेबल है? Magnetic bearing is 44 degree 30 minutes. Okay. Also, you are given with declination as 4 degree 30 minute west. Okay. So, if we draw the bearings, okay, this making the true meridian and true north, magnetic north is very important in solving this question. Okay. So, here this is the true north. Okay. Now, to segregate, I will. Now, you can see the declination is 4 degree 30 minutes west. So, the magnetic meridian will be somewhere here. Okay. So, this angle, this is 4 degree 30 minutes. Okay. This angle. This is magnetic north. Now, you are provided with magnetic bearing. Okay. So, if I draw the magnetic bearing, this line will be somewhere here. This is A, this is B. Now, the angle from magnetic bearing is provided to you, that is 44 degree 30 minutes. So, the true bearing of this line AB, okay. So, true bearing of AB will be, this will be the true bearing, okay. So, what is true bearing here? This is magnetic bearing minus this is the declination. So, magnetic bearing minus declination, okay. So, magnetic bearing was 44 degree 30 minutes, okay, minus 4 degree 30 minutes, okay. So, this is the magnetic bearing here and this is the declination. So, this angle true bearing is for magnetic bearing minus declination, okay. So, this with this the true bearing is 40 degrees. Now, true bearing will always remain the same because true north does not deviate with respect to the magnetism or any other property, okay. True north is always fixed, okay. So, for the second case, now in the year 1990, okay. So, what will be the true bearing? It will be the same 40 degree. What is declination? Now, the declination in question is annual change of 6 degree eastwards, okay. So, earlier the declination was 4 degree 30 minutes west, okay. So, it is 4 degree 30 minutes west and on yearly basis it is changing by 6 minutes eastwards, okay. So, minus and between 1990 to 1910 there are 80 years into 8 minutes, okay. So, if you calculate this one, the declination will be 3 degree 30 minutes east, okay. So, it will shift every year it will shift 8 minutes east. Okay, so in the year 1990 it will be 3 degree 30 minutes east. Okay, so let us draw the diagram now. This is true north. Okay, now declination, due to declination the magnetic meridian comes to this position. Okay, so this angle is 3 degree 30 minutes. Okay, now this is A, this is B. Okay, so here the true meridian you know, that is 40 degrees. Okay, also declination you are knowing. Okay, so magnetic bearing is true bearing. Okay, so this is the true bearing, and what is the magnetic bearing here? This one. This is the magnetic bearing. Okay, so magnetic bearing is true bearing minus declination. Okay, so true bearing is 40 degree minus 3 degree 30 minutes, that is 36 degree 30 minutes. Okay, so this is your answer, and it is option, I think, A. Yes. Okay, so I hope everyone is the concepts are clear to everyone. Okay, you can take a screenshot of this. Okay, so this is for the year 1910. We have calculated from here magnetic bearing. We have calculated the true bearing of AB, and subsequently there we have calculated the declination, and with true bearing and declination we have calculated the magnetic bearing in 1990. Okay. See, with plane table surveying, you should know the theoretical concepts. Okay, plane table what is intersection method, resection method. Okay, traverse method. Okay, you should know those concepts of plane table surveying. From numerical point of view, it is not very important. Okay. See, Raka Chaturvedi Bhattacharya is asking. Okay, see, the annual change is 6 degree. Yes. Okay. See, the annual change is 6 degree eastwards. Okay. So in the year 1910, the magnetic north is at this declination was 4 degree 30 minutes east. Now every year it will shift 6 minutes eastwards. Okay. So with 80 years, this comes to 80 into 6 minutes, that is 480 minutes. Okay, so if you deduct this, this will be 3 degree 30 minutes east in the year 1990. Okay. Okay, please take a screenshot. We'll quickly move to the third question now. Okay. So this third question is of traverse surveying. Okay. From gate point of view, traverse survey is an important topic. Okay, the question related to closed traverse. Okay, I have appeared in gate examination, right? Traverse surveying. Okay. Now, in this, a closed traverse PQ RSP, you are given with lengths and bearings, and you have to find the missing length and bearing. Okay. So, let missing length and bearing be L and theta respectively. Okay. So, you know the property of closed traverse. In closed traverse, summation of latitude is 0. This is the first condition, and the second condition says summation of departure is 0. Okay. So, let us take the first condition. Now, with first condition, you can do is first length into, now here it is north, south, west, east. Okay. Here this is latitude, this is departure, this is departure. Okay. So, here latitude is positive and departure is also positive. Here latitude is positive, departure is negative. Latitude, departure both negative, and here latitude is negative, departure is positive. Okay. Now this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay. So this is the basic diagram. Now here this is into cos 0 degree plus 1000 into cos 45 degree plus 907 cos 180 degree plus L cos theta is equals to 0. Now if you simplify this, L cos theta is equals to minus 0.1068. Now this is equation 1. Okay. Now if you write the equation 2 here, equation 2 is with respect to summation of departure is equals to, okay. So Shubham, please define a designated length. Designated length is the standard length of the tape or chain, okay, which is given to you. If it is a 20 meter chain, 40 meter chain, 100 meter chain, that is the designated length. Okay. Due to some errors, there is some deviation, okay, it will be either less or more, that is the true length, okay, that is the actual length, okay. So designated length is what is standardized, 45 degree plus 907 into sin 180 degree plus L sin theta is equals to 0, okay. So if you simplify this equation, L sin theta will be equal to minus of okay. So these are the two equations which you have obtained. Now to get the value of to get length L, okay, what we will do is we will square the equations 1 and 2 and add those, okay. So if you square and add, L square cos square theta plus L square sin square theta is equals to minus of 0.1068 whole square plus minus 707.17 whole square. So L square is equals to 5 lakh and L is 707.1 meters. Okay. So to get the value of L, you have squared and added these. Okay. So sin square theta plus cos square theta is equals to 1. Okay. So now to get the bearing, that is the tricky part. Okay. To get the bearing, what we will do is divide equation 2 by equation 1. Okay. So this will give you tan theta as 6620.105. Okay. Now if you calculate the value of theta, you will be getting the value of theta to be 90 degree. Okay. But 90 degree is not the correct answer to this question. Why? Because see, the value of L cos theta here, this is the latitude of that line, okay, that is negative, while the departure of that line is also negative. Now if you see the quadrants here, okay, you can see it here. If you see the quadrants, now the latitude is negative, that means it will be either this one or this one, and also departure is negative. So the length L, this length SR, I think SP is in third quadrant, okay, while this angle theta 90 degree is in this quadrant, okay. So in order to bring that here, what we will do is, we will do 180 plus theta, 180 plus 90 degree, 180 plus 90 degree, that is 270. So theta is equals to 270 degree is our correct answer. Okay. This theta is equals to 90 is here, okay, but our this line SP is in this third quadrant, okay. So you have to do 180 plus theta, okay. If it would have been in this quadrant, then we would have done 180 minus theta, okay. So here it is theta, this would have been 180 minus theta, here it will be 270, here it is 180 plus theta, and here it is 360 minus theta, okay. So for finding bearings, these things you have to check. You have to check in which quadrant the line is in, line is getting placed, okay. So the correct answer to this is B, yes. So length is 707.1, theta is 270 degree, B Okay. So please take a screenshot of this. I hope this is clear to everyone. Okay. Now let's move to the fourth question. Now this question is of reciprocal leveling. Okay. And here you have to find the error due to collimation. Now reciprocal leveling is done when there is some obstruction in between the two stations, okay, like a lake is there, a water body, okay. So but the visibility has to be there between these two stations, okay, then only you can take the value of staff intercepts, okay. Reciprocal leveling. Now in this, the station A and B are 1200 meter apart, okay. Also their staff readings are given to you and you have to find error due to collimation, okay. So first of all, let's visualize these readings, okay. So the first thing first, this is, let us suppose this is station A and this is station B, okay. So at this point there is a staff, at this point also there is a staff. Now this instrument is placed closer to A first, okay. Now at this point the first reading is instrument station is at A, okay, and staff reading at A is 1.42 while staff reading at B is 2.74, okay. Now the second thing, now this is when instrument at A, okay. Now second case, this is A, this is B, there is a staff here, there is a staff here, and instrument is placed at this location. Yes. Now in this case, the reading when instrument is at B, okay. So when instrument at B, staff reading at A is 1.44. Staff reading at A is 1.44 while staff reading at B is 2.5, okay. So from the readings you can easily visualize which station is higher and which station is lower, okay. So when it is at A, the staff reading is only 1.42 while staff reading at B is 2.74. That means the station B is lower to staff the station A, okay. So these two are the diagrammatic visualizations of this case, okay. Now we will find the true difference of level between A and B, okay. So if I draw it here, delta H, this is the true difference, delta H, okay. So delta H, the formula for delta H is HB minus HA plus HB dash minus HA dash divided by 2, okay. So HB is 2.74 minus 1.42 plus 2.5 minus 1.44 divided by 2. So delta H value which you will be getting from here is 1.19 meters, okay. So this difference is 1.19 meters, okay. So okay, so this is the value of delta H which you have obtained. Now total error, okay, that is due to curvature plus refraction plus collimation. This is equals to the total error is, okay. So the difference which is provided by these readings minus delta H, okay. So this is the measured value HB minus HA. Okay, so let's write here. Error is measured minus true. Okay, so the measured value is HB minus HA and the actual difference is delta H, that is 1.19. So 2.4 minus 1.42 minus 1.19. So the total error, okay, due to curvature, refraction and collimation is 0.13 meters. Now error due to curvature and refraction, that is 0.0673 d square. Okay, so this is the formula to calculate the value of error due to curvature and refraction, where d is in kilometers and the value of d which you are provided with 1200 meters, that is 1.2 kilometer. So error due to curvature and refraction is 0.0673 into 1.2 whole square, that is equals to 0.097. So error due to error due to collimation is, okay, collimation error is error due to the line of sight. Okay, due to some atmospheric disturbances, it slightly deviates from its straight path and somewhere here. So this will be the error E. Okay, collimation error. Okay, so 0.13 minus 0.97. Okay, so that is equals to 0.033. Okay, so collimation error per meters. You have been asked. Per meter is, this error is for 1200 meters. So per meter is divided by 1200, that is 2.75 into 10 raised to the power minus 5. Okay, so this is your answer. Yes, so option D is correct. Okay. Abhishek Thakur is asking why only HB minus HA I have taken. You can take HB dash minus HA dash, it doesn't matter. The error, total error will remain same. Okay, even if you do 2.5 minus 1.44 or 2.74 minus 1.42, you will be getting the value same. And if you deduct it with delta H, you will get the value same, 0.13 meter. Okay, so you can consider this case as well and this case as well. You don't need to worry about that. They will give the same answer. Okay, please take a screenshot of this. Okay, we'll move to the next question now. Now this question is of tachometer. Okay, so before solving this problem, I will quickly write the formulas for tachometer, which you will be needing to solve the questions related to tachometry survey. Okay. Tachometric leveling. Sorry. Now, two cases arise in tachometry when staff is held vertical. Okay. Now, in that case, D is equals to Ks cos square theta plus C cos theta, and the vertical distance is half of Ks sin 2 theta. Sorry. V is equals to half of Ks sin 2 theta plus C sin theta. Okay. Now, when the staff is held normal. Okay, so D is equals to Ks plus C cos theta plus R sin theta. Okay, and V is equals to Ks plus C sin theta. Okay, so these two cases are with respect to staff held vertical and staff is held normal. Okay, and these are for the inclined sides. Okay, now for the case which you have taken here, that is for the horizontal side. Now in a GATE examination, the question related to tachometry are more of extracting data from the numerical. Okay, now as you can see, there is a lot of theory mentioned here, and you have to extract the values. Okay, so the first thing is given to you is focal length f. The focal length is 240 mm. Also, the distance between vertical axis of the tachometer and optical center of the object glass is 120 meters. Now, this is small d, 120 mm. Okay. Now, the third thing is spacing between upper and lower stadia of the diaphragm is 4 mm. That is nothing but I value 4 mm. Okay. And the staff intercepts are given. So, staff intercept S will be upper minus the lowermost. Okay. So, that is 1.6 meters. Okay. Now, as you know, the formula is D is equals to Ks plus C. Okay. Here K is F upon I, multiplying factor. Now, F is 240 and I is 4, that is 60, while C is F plus D. Okay. So, F is 240 and D is 120, that is 360 mm, that is 0.36 meters. Okay. So, these two constants we have calculated. Okay. Now, we will put the formula and get the answer. Okay. So, D is equals to K value is 60 into 1.6 plus 0.36. Okay. So, this is 96 plus 0.36, D is equals to 96.36 meters. Okay. So, the correct option is B. Okay. Please take a screenshot of this. Okay, this was an easy question. Okay, I have already enumerated the formulas. Okay, for vertical, for normal, and for horizontal side, we have solved the question. Okay, so you should be remembering these two formulas, these 4 formulas plus one this one. Okay. Yes. Let's move to the 6th question now. Now this question is related to the photogrammetry. Okay. So in the recent pattern of the GATE examination, a lot of questions have been asked every year. They are asking the questions related to photogrammetry, and that is with respect to the aerial survey. Okay. Numericals related to this topic. Okay. Photogrammetry. Okay. Now here, let's read the question. A line AB appears to be 10.16 centimeter on a photograph for which focal length is 15 centimeter. The corresponding line measures 2.54 centimeter on a map which is to a scale of 1 upon 25,000. Okay. The terrain has an average elevation of 300 meter above MSL and the flying altitude of the aircraft above MSL when the photograph was taken. Now we have to calculate the value of flying altitude. Okay. So, photo distance is 10.16 meters, map distance is 2.54 centimeter. I think this is in centimeters. Okay. focal length is given to you 15 mm, 15 centimeter. Okay. Also the scale is provided to you of 25,000. This is the map scale. Okay. And also H, you are provided with 300 mm, 300 meters, sorry. Okay. So let photo scale, this is map scale, photo scale be 1 upon x. Okay. We have taken photo scale 1 upon x. Okay. So photo scale by map scale is equals to photo distance upon 2.54, that is map distance. Okay. So we have simply taken the scale on both sides. Okay. So these should be equal. Now from here, if you simplify, the value of x is 6250. Okay. So this implies the photo scale is 1 upon 6250. Okay. So now we know the scale is equals to focal length upon h minus h. Okay. So the photo scale is 6250. Now the focal length here is 15 centimeter, that is 0.15 meter upon flying height h we have to find, and small h is 300. So if you simplify this value, the value of h you will be getting is 1237.5 meters. Okay. So the correct option to this is C. Okay. Shubham is asking, sir, what is S? I think you are asking in the previous question. Now S is the staff intercept. Okay, so if you see, there is upper steady reading, lowermost and middle. Okay, so S is this value here, and that is the uppermost reading minus the lowermost reading, that is 1.6 meter, this distance. Okay. Yes, Abhishek Thakur, your answer is correct. Okay. So please take a screenshot of this, and we'll move to the next question. Okay. So this brings us to the last question of this session. Okay. Now this question is also photogrammetry and related to the relief displacement. Okay. This is also a very popular topic. Okay. So a section line AB 300 meter long on a flat terrain measures 102.3 mm. Okay. So from this data you can find the scale. So 102.3 mm on photograph measures 300 mm on ground. So the scale you have obtained is 1 upon 2932.55. Okay. So this is the scale. Okay. So this is the scale which you have got. Okay. Now H average. Average elevation is 553 meter. Okay. So Ravi Ranjan will be discussing concept related to this one. Don't worry about that. I have discussed one type of question. Okay. The previous type was related to the scales. Okay, in photogrammetry, and this will come clear the relief displacement topic. Okay. So don't worry about that. Ashish Kumar, ये सब previous year है क्या? नहीं Ashish, these questions are not previous year questions. Some of them, one or two maybe, but not. These are not previous year questions. Okay. So now this is the H average value. Okay. So now let us suppose this is the ground elevation. Okay. And here there is a tower. Okay. So this is the tower. Now at this location there is a aeroplane in which a camera is fitted at this location, let us suppose. So this is the line of sight from top and this is the line of sight from bottom. Okay. So let at this location, this is distance is equal to f. Okay. F you are provided, f is 152.4 mm. Okay. So at this location, if I draw the vertical line, okay. So let this point is O, at this point is R1 and this is R. Okay. So this is R1, this is R and this is O. Okay. So the distance, this one, this is the relief displacement D. Okay. So there is a difference of distance between the line of sights of top and bottom, that is the relief displacement. Okay. So from the figure you can see O R1, you are provided with in the question you are provided the distance measured from the principal points to the image of bottom and top. Okay. So OR1 is 70 mm and OR is 80 mm. Okay. So this is relief displacement meant D. Relief displacement D is OR minus OR1. So D is 80 minus 70, that is 10 mm. Okay. So this is the relief displacement, that is OR minus OR1. Okay. So 10 mm is the relief displacement. Okay. Now you have obtained the relief displacement. So now scale is F upon H minus H average. Okay. So the scale is the scale is 1 upon 2932.55 and focal length is 152.4 into 10 raised to the power minus 3. Okay. To convert it into meters. Okay. Divided by H minus 553. H average is 553. You are provided with 553. Okay. So the value of flying height which you will be getting from here is 1000 meters. Okay. Now what is your target here? To calculate the average elevation of the terrain, the height of the tower. Okay. So you have to calculate this height H. Okay. So you have calculated the value of this flying height. Okay. So now we will move to the formula of relief displacement. Now you know the formula of relief displacement, D is H into R upon H minus H average. Okay. So put the values. So 10 mm relief displacement D is 10 mm. Okay. Let's convert it into meters. H, small h, you have to calculate. Okay. R is 80 mm, convert it into meters, divided by H you have calculated 1000 and H average is 553. Okay. So from here the value of H you will be getting is H is equals to 55.875 meters. Okay. So NET type, so no options. So 55.875. Yes, Ravi Saxena, your answer is correct. Please don't round off that value. Shivam, yes, your answer is correct as well. Okay. Please, Shivam, don't put the question mark. You should be confident in writing your answers. Okay. So please take a screenshot of this. I hope this concept is clear to you. Okay. Of the vertical aerial photogrammetry. Okay. So this brings us to the end of this session on surveying. Okay. Now in the subsequent, Abhishek, R cannot be 80. Okay. So Please don't confuse from here, okay. See, this distance is r, while this distance is r1, okay. Remember this diagram in your mind, okay. Engrave this diagram in your mind and you will not get confused with respect to the data, okay. So this brings us to the end of this session now, and I hope this was helpful to you. In the coming session, we will be discussing water resource, that is irrigation and hydrology. The session will be on either on 31st of January or 4th of Feb. Exact date will be communicated to you, okay.